data networking is. Now there are types of network. There is PAN, LAN, MAN, and the WAN. Now I want to see that this thing came about in terms of architecture, in terms of sizes. Because if you look at the PAN, it's more like a personal area network. Now what is personal? Your devices are personal. Your Bluetooth connections is personal. These are between a short range, like few meters. You understand? You're able to communicate with your phone to your Bluetooth headset when they are close. If you carry your phone, go that route now, your Bluetooth will disconnect. So now that is the connection between that. The technology they said that it is using, it's more like Bluetooth, USB, and sometimes Wi-Fi. Obviously, we know Wi-Fi can connect over a short time, right? Now, examples, connection between your smartphone and your Bluetooth headset and everything. Use cases ideal for personal devices and close proximity. Very self-explanatory. Now there is LAN. LAN is what you will see most people actually use because it's more like something that covers a medium space. Now this whole house, go my code as a building, you're using a router or whatever, you're using a LAN. It is between like a medium size school, a home and office. Do you understand? That is you're running a LAN. Do you understand? Most times you can do it Ethernet by wired cables, right? You can connect your switches and everything, connect everything. Sometimes now, what we most likely practice is wireless, right? Wi-Fi. Now, the device is connected, you can connect your computer, your
connected this.
Do you understand? Yes, this is all there are connections running. They are over the Wi-Fi. It's wireless connection you need to TV, right? Now, if it was not wireless, you would use HDMI, which is like an Ethernet cable and all that. So now there's protocols that you use Ethernet or Wi-Fi. Now you can see where they describe Wi-Fi. There's different types of there's 872, there's 11. You would get familiar with all this as time goes on. Do you understand? Use case, efficient for use in fact networking within compounds, like you understand. Now there is metropolitan area network. We all went to some of us we all been to university where our school has like went to music, my school had like Wi-Fi, school network. Now that network, for it to have covered that range of that university, some of us are working in companies that are wild.
Or airports.
Yes, you understand. Now those people are people that are participating in the metropolitan area network. In which, how are they doing this? It is one router connecting from one router to another router. You understand? To cover that size. Do you get it?
So they connect like 5 routers together out there.
More like that.
Just one connection.
Build that unique connection, covering that metropolitan area network. Correct me if I'm wrong, though. Do you get? Some of you are well experienced in networking, but I'm trying to explain it how I know it. Now there is wide area network. Wide area network is in this way that you find the internet, which is like across continents, across countries. Do you understand? This is like something. While they achieve this one, the other one can be achieved in relays, phone relays, like joining routers to routers and everything. The other one can be achieved with relays too, like running fiber optics. Do you understand? Okay, now fiber optic with high speed backbones. This one is still fiber optics. You know how the ISPs, people that got them, what the internet about, they run like lightning cables around and all that, even in the oceans.
Yes.
You will see lightning cables, fiber optics there. That's how we connect, and then there's like one big internet system. The whole that's why you buy things from ISPs, they are making their money. MTN is just a little fracture of that internet money. Do you understand? There's people that is still global, and I don't know how to explain it, but just not a hierarchy in it. But this is especially what networking is.
So basically, MTN Glo is an example of what
they are ISPs. Those people are internet service providers. They are internet service providers. They are not like the type of network they are running now can be a wide area network or metropolitan area network. Like it just runs across continents. It can be metropolitan. No. It can be a wide area network. Yeah. It can be a wide area network. Yeah, but just know that all of them is what forms the internet that you see. Do you get it? And now everybody is connected to that one body for you to be able to connect on the internet. Do you get me? So now come down. We'll see the comparisons. I'm now about to come and be making comparisons with you people. People are supposed to please go up. Calm down. Now there is network ownership. Now can be private. This one, that one, the other one public. Area covered, small, medium, large. Design simple, moderately complex. The other one is very complex. Obviously, self-explanatory. Now there is something called bandwidth. Do we know what is bandwidth? And
Like the speed.
Hmm?
The speed of the network.
Is it the speed? Is bandwidth speed? Oh, bandwidth is speed, Sha. It's like the amount of data that is allowed to pass through that network. That is the bandwidth. Now there is the throughput. Now let's say this network is allowed to pass 5 megabytes of data. Now throughput that thing that is allowed to pass 5 megabytes of data, now you will see that it is 3 that can successfully pass. Do you understand? Now maybe in express now, they tell you say this express now fit occupy like 5 cars. But at the end of the day, you see that it is 4 that can confidently pass. Now that is what is the difference between bandwidth and throughput. Do you understand me? Now that is high in land. There is no congestion. Your small network, wetin you dey like, e be like say maybe if only you dey waka for express with a small area network, you go dey waka quickly, so it's very high. You understand? The amount that will eventually pass will be very high also. Same as this thing is self-explanatory. And where that it is only you that is working maybe in the land, it is only you that has the low express, the congestion will also be low. Yeah, so that's why you see that if too many people are on the same network, you see that congestion will kind of increase and kind of be running slow. Please, not be story. I'm not about people here. Like, I'm not telling stories. Yeah. Typical use, obviously, we know the use, we've talked about it. So that is it about network and the types of network. Okay. Now let's talk about OSI model. Who is going to?
Sorry, can I ask a question? So
Yes, please.
I don't want to take your time.
If you want to take, I will follow you to check out.
So for instance now, you see if you connect your printer to a laptop and you send an information, you assume that it passes through the wire cable. That process, does it have a different name than what he is doing now? He is using wireless to send an information to the TV, right? There's no wire. What's that process for?
What is data networking? What is data networking? And what is the difference between PAN and NAN?
Okay, so
PAN uses Ethernet cables, external stuff. So it's a network. It's network. You're sending data to devices. You understand? They are all network. It's the same technology. It's just that you're using a different means. You're using a wired cable that is sending it USB. Now there is wireless. This is people that is. So it's the same thing. It's not really. So it don't go far. OSI model. Who be that? 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 Who is so cool? Mr. Victor is so cool. Mr. Victor, take us away, please. Please, guys, is the class assimilating? Is it following?
there's no coffee.
Is there an allow why una go put 9 for the quota? So that they put 10 for there. Eh? As long as you come begin, you will be fine. That is why I'm telling people that they win money for year. Like normally class, people they come. Even my Valentine Day, my students gave me gifts. Sure you were there, Mr. Victor.
I wasn't on
You were on that Valentine's Day now. My student gave me gifts. So I suppose they carry things they come.
Oh, really?
Yes, now.
Another bad.
Now, guys. Who is the okay? Mr. Victor.
Sorry.
OSI model.
The OSI model, standing out for OSI model is like an open system interconnection. It's a concept, it's a particular framework used to understand
Okay, now read the reader. All of them are they use the same format.
and troubleshoot network communication. It breaks the communication process into 7 layers. There are 7 layers of OSI model. You have the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. I think you made mention of please don't
Throw sausage.
please do not throw sausage. These are really, yeah. So, but I'm seeing in the upper layer, it's divided into two different, so the upper layer and the transport service. We have the application layer that is the message format.
So, what does the please do not show because I'm confused.
It's the acronym for that is the 7 layer.
Oh,
Yeah.
That's the application of the 7 layers of works.
The upper layer has the application layer.
why is this 5 sausage?
Okay, thank you. Yeah, good.
The upper layer has the application layer.
Take teacher for first greet. First ask you good. Okay, that's good. That's good. It's good. So now, OSI model, guys. Mr. Peter was doing a good work explaining it until I stepped it because I won't cover a lot today. I want us to move as quickly as so I will not be lagging in the class. So guys, OSI model more like before when they never developed OSI model, different companies they are dealing with networks. You understand? They are building networks and everything. But there was no actual like method they were following or something. They were just building methods, and most times if you have network issues, you will not know where to like troubleshoot. If you have errors in your network, you will not know where to troubleshoot, where this thing is coming from. Before a body, whatever body, came together and they developed this OSI model. Now it is a framework that shows you like how data moves. Like I want to take it as the life cycle of data. How data works before it is being delivered. Like you send data, what it passes through. You understand the process it takes before it is successfully delivered. Does it make sense? Yes. Now there is 7 layers in the OSI model. Although recently there is the TCP IP that is now, I think that one is 4 or 5. And now that one the assignment. Assignment is TCP IP, guys. IP. B. Okay, now let's do your third. Assignment is just the truth.
Because international organization.
Yes. I like the fact that it's, even if like I feel the jabber they tell them anything, I feel they chop up. No, that they take online, no. Guy. So there is the 7 layers of OSI model. Now there is the physical layer, the data link layer, the network layer, the transport layer, section layer, presentation, and application. Now it can be a bit difficult to like memorize the way it comes. That is why the acronyms, popular acronym, came out. Please do not throw social media away. Now, please is the physical layer. Do is data link layer, not network, through transport, sausage, section, presentation, these are the other one away. Do you understand? It's more like so that you can be able to like have memory of like the way it is aligned because it is really in that manner. Do you understand? Now in the physical layer, that is where it works with like the physical components, your devices. It's usually, computers, they communicate in ones and zeros, right? Yeah. The computer language is ones and zeros. All these things they are seeing now, for it to activate, it has to be in ones and zeros. It communicates like that. Now in this physical layer, that's where you see hub. Although hub is going obsolete. Hub, there's 3 types of devices. There's hub, there's switches, there's routers. So hubs is the one that generally just puts that when you send something, it takes it to everybody in the network. Then switches is the one that when you send a message to it, like when you're sending a message, it's cooperating layer to the data link. When you send a message, it looks for that person's MAC address because we use MAC address to send message. In that way, it's now looks for the MAC address and delivers it to the person. If you know they, that's when it will now broadcast it. If that MAC address is not registered on the switch, that's when it will now broadcast it to everybody, and then the person that has the MAC address will now be the person to reply back. You will get them. Just hold it in your head. Do you understand? The router is the one that is still like takes it, uses IP to identify where the network, the data is going to. Now the physical layer.
Or when the data is connected to.
When the data is going to, connected to where it's going to, like, data you can send back to yourself for understand. Use IP to know source, destination, and destination, whatever. So now physical layer is like the one that does it. Please, if I want this done, I can randomly pick anybody to explain the OSI model for me. I like my class being discussive. Is that a good language? Yes, we can add to. So now physical layer, like ones and zeros, transmissions, but data link, it's more like it manages communication within a local network. Now, this kind of places, it doesn't have to like deliver data, it doesn't use the internet. It doesn't use the internet, it uses MAC address. We all know what is MAC address. This was the full meaning of MAC. MAC address. What's the full meaning of MAC address? I give an acronym in class. If you don't know, I will not go forward. Because everybody will do it. Everybody will answer it.
Media source control.
Sign on it.
Media source control.
So that don't do my assignment, but they were right.
Which assignment?
Yes, now I gave acronyms. If people did not, if people did acronyms, people are supposed to know media access control, MAC address. What is IP address?
Maybe we not take mark, that's why.
We think about like, yeah. Do you understand? People supposed know all these things. Do you understand? People will get it. Don't mind me. I'm just trying to dramatize it so people will be pushed to go and know. So now, MAC address is more like it's MAC address. We'll get there. I think it's in the next frame, sure. But just know that MAC address is like the one that the manufacturers give when they put a network interface card in the system. They give it a MAC address. Every system has their own MAC address. It comes with the manufacturer. Okay, so now MAC address and frames. It uses at layer 2. That's where you see MAC address operating. It uses MAC address to identify where the source and the destination of the distance. Sorry, please guys. Nami, yes. She didn't call you. Yes, call Nicole so that she knows if you have to come or not. Alright. So now, data link. Now this is where like it uses. It's more like you are enveloping something. You are sending a message. In the outer envelope, you use MAC address. Now, if you use MAC address to locate the particular thing, if that stuff is coming in, if you don't pass network, you don't enter the router. Router has to use MAC address to know the particular place where you send the network goods. So you understand? These layer 2 switches are MAC address. Know it into your brain, please. Then network layer is where you start seeing IP. IP is internet protocol. You start seeing router. It handles IP addressing and routing. Routing is more like telling this thing, you're going to this place. IPs are identifiers on the network, right? IPs are particular, IP is like name on the network. MAC address is like name on the physical device. Do you get it? MAC address, name on the physical device, identity on the physical device. IP is identity for the network. Do you understand? Now you use IPs to now say, okay, this one is going to this social IP. You use it to identify, and it operates. The router operates on that layer 3. Now there is the transport layer. The last assignment, I did not give TCP, UDP stuff. Nothing. Wow. Now don't escape this my assignment. I don't like when you escape things like this. Now there is transport layer. This is like transport layer is like it's more like a path. When you tell somebody you're going to house 3, IP you're going to have to identify the IP that is going to. Now, for that data to move, it has to take it has to move from that point to this point, that transmission, that's transport, that's you know sabi transport now. The fact that it's moving from here, there is different methods, there is protocol that is happening there. Now you talk about the TCP and UDP protocol. Now we will talk about it in the next slide. Just understand the whole thing that the TCP, UDP transport happens on the transport layer. Do you understand? Please, are we getting it?
Yes.
I know we read about it. This is more like solidifying. I always solicit that my students will. Now there is the section layer. Now section layer, whenever you log into WhatsApp, when let's say you log into your Instagram, you open your Instagram, you log into it, you establish a section. Now, the time you stay in that Instagram, that's your section. You close that account and go out. You have ended the section. Do you understand? That's like a section because that controls the setup. Like the section for that data to be transmitted is the section. Do you understand? Now, if you are having a problem that maybe the data has passed transport layer, the next layer you are supposed to troubleshoot as the section layer. Do you get me? Do we get? Now there is the presentation layer. This is when now you can be transmitting something over maybe transmit something using HTTP and HTTPS. Who can tell me the difference between
Encrypted and not encrypted.
what?
Encrypted and not secure.
Yes.
One is secure.
So now you see that if you're sending a message now using HTTPS, you most likely encrypted, right? It's encrypted, it's secured, it's encrypted because nobody can hijack it and be able to read it. They have to decrypt it for them to read it. Now, if you're coming to presentation layer, the fact that that data is moving through that secured layer, encrypted format, if it gets to the presentation layer, the device that is supposed to go, that is when we encrypt it or decrypt it for that user that is intended to receive the data. Please, are we getting? Is the class feeling sleepy? Maybe we jump up small.
Sorry, so how about
Maybe do you have a question? You want to start from? Guy, Jesus.
You see,
if you log in, if you want to come into your WhatsApp, right? The time you enter Go My Phone, you open the section. The time that you took is spend with here. Once you leave, the section has closed. Do you understand? Just take it like that. It's the section. That is how time spent for that message to be delivered. Do you get it? Now, presentation is like when you translate, when you encrypt, when you you understand when it's coming in and in an encrypted format, you have to transport it in an encrypted protocol. It's encrypted. That fact, if it not gets to where it is, the user has to receive it. It's decrypted. Now all these things happen, but in milliseconds, that's when you see message just sent. You will not know this is what's happening behind the scene of when you're sending the data, when you're communicating on the network. Now the application layer is the interface, the software that the user used to see the stuff like okay, user interface like web browser, email client, whatever, like software that you are using to see is an application. WhatsApp is an application, right? Instagram is an application. Even Google self is an application. Chrome is an application. Gmail is an application. Do you get? So now that's where you see them. Is the OSI model clear?
Yes.
Now this is why do we need the OSI model? Please can somebody just read? Come down. Now, why we need why? Just
Even though the modern network often use simple TCP IP model, OSI helps in diagnosing problems and designing network system by breaking down the communication step into clear, understandable layers.
do you understand? I told you people that in recent times, OSI model it's more broken down because it has 7 layers. Now in TCP IP, I think that's like 4 or 5. 4. 5. So now some of them are packed into one in TCP. But it's almost likely the same thing, but it's TCP IP that people are using. That's why I gave that an assignment. Go and read about the model. Once you've understood this OSI model, TCP IP will not be much of a struggle to understand. So next class now, if we come with the capital assignment, we will understand that. But it's not much of a difference. Do we get it? Now, why do we need OSI model? It's for troubleshooting. Like maybe in a case where data going, and you be network engineer, when they tell you, say, oh, network is disturb, this data not be, you are able to step in and see at what layer you will be able to start your troubleshooting. There are some data that they have passed the MAC address layer, data link layer, they have passed the networking layer. It's in transport that they now have command KLM. You as a network engineer, when you go in deep, there is CCNA. You are doing CCNA, understanding network of going deep. You will go in more in depth. This is just like eyes on the shoe. You just have to understand them. Because when you are doing, if you are even hacking into somebody, you will see data. If you understand this OSI model, you know when you will steal data. Do you understand? You know when to hijack data at some point. Do you understand? So this is just normal something. Even as you go deeper into cybersecurity, you even understand deeply. But this is just the normal level you are like understand. Yes, please.
For instance, I want to send you a message. That's a data. So if I send you a message on WhatsApp and immediately I turn off my data, what happens?
If you turn off your data, now if you say you probably, if in that milliseconds, because these things happen in milliseconds, like as fast as you cannot even just if you turn off it, if it has been that maybe that message has not gotten to the network layer, you see maybe from your side, your network layer will be dying. Now, if you want to troubleshoot, if somebody is going to, they will come and turn on that network layer and it will become complete. But if it's that it has passed the network, please are we evil? I will teach you people evil. Mr. Nandi, I go back. Shaba is evil. That will enjoy me. Yeah. So, like, if the person troubleshoots, the network can be. But if your network has been, if within that milliseconds has passed the network layer, and you depend on your phone, you depend on your phone. You understand? So, are we good?
Yeah.
Now let's take the camera in the casing. IP addressing fundamental. Now there is IP addressing. Please, discussion class. What do you understand as IP address? Like I really have spoken about it, so I'm just going to pick randomly.
IP address is
Like say you know say that you are going actually. So just give us the
IP address is like an identifier to indicate that this IP or this network belongs to a particular person.
Okay.
So yeah, it gives that direct identification that this IP address belongs to this MAC address.
Okay. At what layer does the IP address work on the OSI?
When it's connected to
Wait. Everybody is confused.
I'll come and do the question.
Okay. At what layer does IP address operate on the OSI model?
I think it's top of layer.
Nothing but.
Sorry.
Shoma, are you clear on that? Yes. Network, right? Are you clear on that?
The network layer. Yeah, and those IP addresses.
Okay, sir. So lead us on. Let us know. Where's my board? Can somebody buy marker for me? I don't know, but should we treat this subnetting when these guys are annoying me? I'm not going to wait for anybody. I guess they run as quick as possible, so I will have time to like find more bigger fishes. And somebody just go and buy marker now. That's outside.
Yeah.
Now 500. Just buy 9
Let all of us.
And one person should bring the board in the other class.
Where's the board?
So, like, we have have 11:50. We don't have time. It's not that bad, please. Shay.
Someone, right? I like your handwriting.
Yeah, very much. How many games? How many games?
One back. One foot back.
So,
Wait.
you walk
More like
my life or
I mostly tutor. Yeah, but I'm more like I do practical. I teach you hands on. This one guys are doing a theory. Okay, fine.
Because I'm looking at it, and after this, probably want to maybe like a 1 month
Hands on.
or yeah.
That's the best approach. That's I did this class. But just to find somebody that will teach you well. The class is good at it. Then we have to pay him like massively.
Yeah. I'm looking at it, but I don't know if he has the time.
I really doesn't. So he might. It's crazy.
Even if it's the whole night, I don't mind.
Mm.
Even if it's night, I don't know.
People they sharp. People see they will do. They forget.
Because though my phone is supposed to give us access, yeah, because we think
Every company have how they operate. I think in your this thing you sign the something.
Yeah, I saw it. I can choose to go out printing this.
Yeah, you can choose to print it. Yeah. You can choose to just copy it and put it in the car.
Or will you copy?
Put you could try.
Okay, just
What's the scriptures?
Special you get not book.
I think that's what I'll just copy it and create
Screenshot it, put it in the folder. You don't know that speak like Jesus Christ. Nice.
You know what I mean?
How far? Should we go now?
When you go, now no one carry the
What's
board.
the word?
I think it's the other class. I'm going to use this subjecting. There are two things. No. When did I come to the micro? Was it not last year I came to the
Last
I
year?
started cybersecurity last year. I walked into there very naive, nothing, didn't know nothing. I was like, you guys are really up to Mr. Clive, you need to keep testing this class. Normally, my other students, I used to go and call him, Mr. Clive, please come, people are serious with their life. Come and try. Price West, my guy. My guy. Eh? I need the word. I be alright. Yeah.
Wow, she like.
I think it's really the front out. It's really the front out. You guys see them step out. But they're not supposed to. But don't worry. Just come up. Yes, they can. Is it classmate? Hold on, sit down.
Yeah.
Yeah.
Okay. See? Abi, but you dey on one already now. Maybe you guys see why did you say na me sef you wan call me? Eh? Oh, na that one dey sweet pass. How far na? Okay. Just a quick. Yeah, just a quick. Away. Away. It's not permanent actually. It just has dried a lot. So, I think maybe we will use it.
Use this one, it's white.
You know, go still white. I don't struggle with it.
Let's touch a little bit of water.
Okay. So guys, IP address is more like a unique identifier for stuff
Yes.
on the network.
Yes. Do you want to sit down here? 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 Can switch.
I think it's off.
Yeah, I just have to for a while.
So guys, IP address is a unique identifier assigned to each device on the network. So if you're a device now and join the network, they will give you an IP address. Now I don't know, there is a before page. I don't know if we should treat it before we come back to this stuff. There is a front page, or we'll be really quick in treating it so that we'll be quick. IP address is a unique identifier on it. It helps routing data to the correct destination. We are going to do subnetting. I'm going to treat that stuff and do subnetting today. But can somebody time me? What's the time now? 11:52. The class is ending 1. Yeah? 1:50. Okay, I have class as exactly. I have class I'm taking by 2.
Oh,
Like another class.
let's do that 1:30.
Your post class is ending 1.
You can do one for
Started 1:30.
But the way you will like this class, it's not boring. Are you not supposed to be sleeping?
Why?
Okay, guys. As exactly
1:30.
what's the time now? 11:50. Almost 12.
Yeah.
Okay. Let's say we discuss the things quickly. We'll come back to this subnetting because there's calculations we will do. Now, IP addressing is a unique identifier assigned to each device on the network. It helps in routing data. Let me just see. I will come back to the calculation. It helps in routing data. IPv4, IP address have IPv4 and IPv6. IPv4 simply means what? I'm asking you guys. IPv4 is what?
IPv4. Internet Protocol version 4.
Yeah, you see her. Yeah, you see her.
No,
So with that, IPv6 is what?
Internet Protocol version 6.
Nice. So that is it. IPv4 is Internet Protocol version 4. Now they came up with it when they developed Internet for something. But then IPv4 is a 32-bit value. Now 32-bit value typically written in dotted decimal notation. I will come back to explaining this. You understand? IPv4 is a 32-bit value written in dotted decimal notation. You see that IP there, 128.8.3.31. That is how you get IPv4. That IPv6 will look somehow like a MAC address. That's it's 128 bits. And who is sharing the screen? Can you type IPv6 so that we see like example of IPv6? This is how IPv6 looks like.
Mm.
It's 128 bits. You understand? Now, IPv4 has a placement because it is 32 bits. It has a value of 4.2 billion IP addresses and it can give out. Do you understand? It's 32 bits. It has a place like you can make out 4 point something billion, 4.2 billion. I think. Make I get guy. Yeah, 4.3 billion values of IP. And if you look at it now, everybody cannot have an IP, right? If 4.3 billion IPs is out there, there's obviously more than 4.3 billion people in the world using the internet. You understand? So it was going into exhaustion. Like they were using it, it was getting like it's not even rampant, it was getting finished. You cannot assign it to everybody. People don't pass that don't pass that. So they have to like find a way and created IPv6. Now IPv6 there is a bit of like slow-mo in transitioning into IPv6 fully. I think they created IPv6 is now 128 bits, meaning it has placement of the break scale enough to go around.
So there's a probability that there will be IPv8 also in years.
Now I'm telling you that IPv6 done the break scale, like exponentially. I don't know where human population will pass that. You understand? But because of the transition, it's kind of like slow. Some companies, so many people, they don't really know how to like transition into IPv6. You understand? Now they are just trying a way. Some people are managing this IPv4. They are still managing it because that is what everybody is conversant with. If you bring new innovation, it will take years for people to like key into it and use it everywhere. If you open your terminal,
Sorry, but what happens if IPv6 get exhausted?
You now that time you don't become a network engineer. You don't create an IPv10. Yes, now you go create you don't know.
But wouldn't that be a problem? Like for real?
And maybe they will still find a way to like they're still managing IPv4 and IPv6 according to what it is saying. It said the nearest future is not exhausted because if you put it like the possibility of IPs you get under it is massive.
It's plenty sharp.
When you start calculating, when you get into IP very well, you will understand that the possibility will go far. Do you get it?
Yeah.
Now, can you clean this? Everything. I don't tell you make you close and clean it.
Yeah. I know.
Oh my God! IF config. No, together. Now I told people to learn basic commands, right? Now if people learned it well, people would have learned IF config and know that it is used to like find your IP. Now you see that @0, it is your network. That iNet there is your IP address.
Yeah.
That's your private IP address. 10.0.2.15. Now, can you find your MAC address and your IPv6 address?
27. This one, right?
That's what.
IPv6. Is it MAC?
08.
Zero
MAC
eight.
address.
No, the IPv6.
It's 08. The iNet 6 is your IPv6 address. The ECA is your MAC address. Do you get me?
Yeah.
The ECA is MAC address.
Yes. MAC address comes in two pairs into 6, right? Yes. Then the other one comes in like 8 pairs. If you don't, I studied a bit of IPv6 when I was doing NetAcad. Not to go my code, I don't even think it's so this stuff now, this stuff. More like another this thing. This ones are supposed to be, I think, 8.
Everything's together.
Yes. So I think this place now most likely 0000. That's why they got stopped. I all the time people that do letter cards, Cisco letter card, there's courses there to do a network. If you want to understand networking well. I did it. It's still part of things that if you ask your CV, you go use am dey reign. As you no do 60 early, you do that one. So now you've seen how you can see your IP and stuff, right? So close this. Let us go back to our IP address. Yes, please. Error one. Is there error? No, it's not error. It's even in his system. Can you put up that? I am not a call person, so you don't expect me to translate everything. I'm not a network, but this ROS, you see error in his own. Make it smaller. I don't know why this was not small. Make it smaller. Okay. Make it more small. Sorry. Good. You see this stuff? It is received packets, and this TS is transferred packets. Received data, transferred data. So according to this stuff, you received 8 packets and you transferred 71 packets. So this one now, this one you see loop is always your loop back address. Now loop back address. I don't know if we're on social media. There is people, tech people, you're on social media and they want to tell them, ask you where are you? But just tell them the coding 127.0.0.1. Usually, if you see a tech person speak that language, it's not like telling the person I'm home. I'm in my house. So this loop back address is like an IP address you can always use to point back to yourself. Do you understand? Yes, it's a loop back address to yourself. To that device, every device. 127.0.0.1. It is 127.0.0.1. It's the same thing. It's assigned, it's set aside for you. It's your loop back address. If you use it to send packet, you're pinging yourself. Do you understand? Yes, I've seen it. Like, you understand? I've seen people do it. So, yeah. So, that is it. We'll understand by today. If we do this subnetting, we'll understand what net mask is. We'll understand what broadcast is. Do you understand? So, Mr. Victor, they are ahead of this. So, let us go on. Now, there is IP classes. Go on, please. Come up. Now, there is IP classes. There's a way that they classify IP. There's class A, class B, class C, class D, class E. Now, these are ranges of IP. If you see IP from 1.0.0.1 to 126.255.255.254, you understand that is a large network. Now, in IP, I will get to explain IP very well. Where I will state that IP is not the past 255. But make we just go and come back again because we will do some calculation. I want to just quickly explain other things and come back to the calculation. Now, this is a range. Do you understand? A range for large network from 1 to 126. 126. IP address from like each octet, there's octets. We'll get to it, Sha. So in class B, you will see that in this range now, it has omitted 127, right? Yes. Which is your loop back address. They don't class it, it's for you. It's an address for your home, for yourself. Now there is 128.1.0.1 to 191. That is a medium-sized network. Do you understand? And then there is 192.0.1.1 to 223, whatever. The small network.
So what do you mean by small network? Is it like the route or the connection?
It's just the classes of IP. It's how it is classed. Class A, B, C.
So, for example, now our home network we're using now is under 192.223. Like it's within that range.
Yeah. Can you check whoa.net?
Okay.
Whoa.net. Who are? Not. Oh.
So your own is A, classified under A. So
Is it A?
this one is B.
What's yours?
My own is 162. That is A. A. My own is A.
Are you connected on Go My Code network?
Yes.
Mine is 102. Yes, we are all
Everybody.
Are you on Go My Code network?
But this person is B. Person is in this one.
Eh?
Yeah, but it's B.
Which access point? Which one? You want? Can you 2.4? Can you be on 2.5? Check.
2.4. You want 2.4? I don't want to change.
Check it. What the next? Please, have you joined that network? Have you Hua.net? Please, every other person on Go My Code network. Hua.net. Please. Be connected. It's lagging. Wait. Okay, because you off your network. Yeah. Let's take it. 102. One class of IP plans. Can you refresh this?
That is A. Class A.
Is this the same thing for everybody? This is the same thing for everybody. Okay, now. This is the class A.
Yeah, because yes, I'm still on one network.
And this is Go My Code router. This is, if you did IF config, you will see a different IP address. Nobody is asking me. What's your, can you go to that terminal? Why you did IF config? This is a different IP. Now this is your private IP. Go My Code is your public IP. That is why I did not want to go in there on this IP stuff. I wanted to first of all teach the terminology that is in the next page before I come back. So that when I'm explaining it, you understand what is happening here. So go back to your listing. Hold the questions, hold the why, hold everything. So go back to your Go My Code. Now these are classes now. Is in range. Now any network from 224 to 239 is used for multicasting. Multicasting, radio stations, stuff like that.
TV station.
People that use broadcasting.
Streaming.
They have this range of IP.
Switch.
Now there is E, class E, 240 to 255. They are set aside for research and for experimental purposes by the government. So, as a cybersecurity person or as a network engineer, now you see a network of 240. You will not say, that they experiment with this stuff. Do you understand? You know that normally the network would not just go and give it to just anybody. Do you understand? Yeah. So this is it about the classes of IP addressing. Coming down. Now, if you look at that class now, there is something called network ID and a host ID. Now, in network ID, like they usually set aside in class A, that's the large network. But since class A, that is large network. In large network, now this is why it is large. In large network, class A network, the network ID is usually, these are like octets. When you see IPs, you see 192, 255, 260, like it's in 4 places, right? Now, if you look at this stuff now, the network ID is set aside for the network. Now, the host, you can put hosts on this other ones, the 3 octets. That is for class A. That is why it is a large network. You have that 3 octets to assign to hosts, to devices on the network. Please, is it getting confused?
This by itself.
Baby, are you okay? Are you following?
You open that word first. So now you are saying that by 1, by 2, by 3 represent this number.
Yes, now. You don't say again for by 1, by 2, by 3, by 4. Octets. First octet, second octet, fourth octet, 5th octet. Now, in this class A, this one is set aside for the network ID. And these ones are given to the host. Do you understand? That means, Abishe, thank you. I'm like, oh my God, I know this will go out. I will hear the tell Mr. Clive say what's happening. See, this one, and this one is set aside for the host ID. Do you understand? In like if this is a class A. Now, if you go back to that one. If you see it now, this class B, 2 of this is taking the network. Is used to identify the network. And then these ones are what you can give hosts. Do you understand? Hosts are devices on the network, people that are joining the network that you can share. But when it comes to a class B listing, this first and second octet are set aside for the network, easy to identify the network. Then you can now share this one. Do you understand? And now, this is class C. Class C, you can see that it is taking the 3 octets for the network ID. And then what you have to share is the 4th octet. And in IP addresses, each octet has a range of 0 to 255. It can only hold 256 places inside. Like if you see an IP address of 257.0.0.0, it can't work. This is not a valid IP address. Do you get it? Because 257 is obviously more than. Now there's a placeholder for each octet. Each octet can be 256 value. But in the sense, just like in numbers, if they tell you base 10 numbers is what? Numbers that base 10 can hold is what? Numbers that base 2 can hold is what? 1 and 0. Right? Base 2 can hold 1 and 0. Base 3 can hold 1, 2, 3. Base 4 can hold 1, 2, 3, 4. Base 10 can hold 0, 1, 2, 3 to 9. Right? Now this is, take it as a base 256. That means it can hold 0 to 255. So if you come across an IP address that has 256, it is invalid. Do you get me? This 256 is counted for the 0 now. 0 must stay valid. That's why it's 256.
But it's impossible to get an invalid IP.
No, you will not see it. Like, I'm just telling you, anywhere where you, as a network engineer, it's not possible.
Yeah.
I'm just telling you, if you see where it is written, you just know that this thing no dey correct. Do you understand? You might be a manager now in your company, and maybe you get somebody to give you a network report and they are reporting 256.
Yes.
As how? Why did you come for networking class? You go show them now. They tell and say this one is more valid. Do you get it? So now, take it that I will come back. I don't want to come and start explaining mathematics now. Let me explain analogies first. So did you see that all these ones? So in this one now, it's as if in multicast, you're giving all this thing to the network ID. It's now going to share to as much people as it wants to broadcast to. And this one is reserved. Do you get it? Please, do we get it?
Yeah.
Do we get it? In large network, you have these three to give to host. There is plenty people that can be in that network. In medium network, you have two. Do you understand? In small network, you just have one. Now imagine in one now, using the analogy that I just gave, if they have just this up there, how many people can be on that network? Somebody do it. How many people can be on that network?
On which network?
In class C.
In class C.
Simple. You can only have 256 hosts in the network because it is just only this one that you can allocate. Now, if you have another thing, I want to explain something. If I have 256, now taking note that I can have 25. Sorry, I think I use value wrong. 255.0.1.255. I can still have 255.0.2.255. Do you understand? That's telling you that in every, if this one change, it's still one of these can have from 0 to 255 units. Is it making sense? I can explain our way because, like say, you know, when I don't get that like this, I go. So please, do we get it? Now, with this stuff, do people get what I mean? That at everyone here, every person here, imagine now this is 255. You can count 254. 1, 254. You understand? Taking this now is showing you that if these two networks is set aside for this class B, how many possible hosts can be in this?
2, 5.
For the class B. My baby, speak up.
128.
Chance this voice.
128.
128
Yeah.
in class B network. How many hosts can be there? Times 2. 255 times 255. Because at each of that 255, each of that 255 has 255 to do. It's more like a parent something. It's more like a folder something. Inside one, you can have the children, another 255 children. Now imagine your grandma had 5 daughters. Each of that 5 daughters has 5 daughters. Now you understand, you times it.
So basically in class 8, you have 255, 255, 255.
Yes.
They can have 0 to 255.
In class A now, how many, somebody do the calculation for me, please.
You have 255 times 3 now. It's the same thing.
Is it 255 times 3?
126.
Calculate it and make it logical. Use your calculator, guys, please. Uyoyo, get to it. Use your calculator. Everybody use it. I need a value from everybody. I don't like how we last people are. Like a phone has like saying I don't deal like that in class.
128 times 4.
Everybody. This is value that I want to be here. Do you understand? It can have up to 16 because as this one gets all these parents, this one said they parent all these ones too. So it's like 255 times 255 times 255 again. Do you get me? That is why it is a large network. Imagine this can hold 16 million
But you said class
hosts.
A is from like 126. So,
Yeah, this is a range. That is a range.
is it?
How did you get it?
Don't worry, don't hold your question. Class, wait, please. 1 minute. She's going to put it through. Ask your question.
When you said this class A is from 126.
This is a range
The range
of what
okay.
it can be. Like from once you see a network of 1.0.0, you know it is a class A, to 126, you know it is a range. But now this is like
Host.
the amount
Host.
of hosts
Okay,
it
from
can
here.
hold. Yes, from here now.
That
It's
is
the
the
amount
host.
of hosts it can hold. Host is devices, people that can join that network. Do you get me?
Yeah, so
Don't worry.
255 times 4
I just want people to be getting at every stage.
Not
So that let us
Not that
times 3, okay.
times 3 because host IDs is taking 3 of it.
Okay, just 1, 2, 3.
Those 2 guys wey no come class, na dem go explain this class for me to know. Please, after somebody can just call them and give them the topics they need. I am not about to go through this spreadsheet again. But they will be fine. Now, no, are you guys? You have not given me values. Calculate value for this. Calculate value for this. Calculate value for this. Please. Let's go.
The class B is 65,000.
Class B, 65,000 words.
Close
Eh?
to 25.
Will you never get that?
No, I thought
I want everybody to get it. I want everybody to understand the concept. Please. Please, as you understand, they put your level. Damn it. You have to teach him. Make sure you understand.
the first
64,770.
is this inclusive?
That's the first one. This one. Okay, this is not inclusive. That's what there is.
So you're not starting from 2, 3, right?
No, it's the host. The host.
Okay,
The
the
host. So if it's class B, the host is from here. Yeah.
So what did you get? It?
255.
Wait, please.
So
Everybody,
class B is
sorry.
255.
Please come and sit down. Class, captain. Who understands? Who understands this thing? Who understands it? Chama, come and teach it. Come and teach it. Yes, come and teach it how you understand it. So I'll see the point you go and I know where to come from. Please, everybody should listen to her. No, baby, go and stand there and teach. In my class, I was teaching. That is why I became this good.
The eyes of it have
The highest, according to the highest number you can get in this place now is 255. So even if you say 254, it means it's not up to the maximum.
That means it's 255.
Yes, 255 is the last amount. You cannot, like she said, you cannot get 256, you cannot get 257.
So it's actually 256. So
Like zero has value.
So if you even calculate it, you calculate with 256. Yes.
256.
Yes. But do your thing.
That's what.
No. It doesn't matter. Just the analogy. That's what I mean.
Okay, so like I said, if this one has 256 and these 3 are given to host, that is the amount of users that are using this particular these 3 okay. So if you do 256 times 256, that's this place has 256 times this 256 again. That's this is 256. That's another 256. That's another 256 again. That's 256 times. Yes. The highest amount. It can be lower.
Round it up there.
Yeah, it can be lower. It can just like what we have here,
But there's no
254.
256 on that place.
Well, that's what
Yes,
she's
the
saying.
line
Because
is
of the zeros.
Guys,
I understand.
wait. Calm down. Everybody should breathe in and sit down. Everybody should breathe in. Breathe in. Now, this is a table. This is a table. This is classification of IP. This is showing you the range of IPs. This is just a range. Now telling you that if you see a range of 1.0.0 is a range. Now this is telling you the the amount of host and ID, network ID in an IP. This is different from this because some of you are trying to confuse this and this. Yes, this one is showing you a range of classes of IP, different classes of IP, class A, class B, class C, class. They are different. Now, this is still almost the same thing, but they are trying to explain why this is a large network, and this is a medium-sized network, and this is a small network. Do you get it?
Yes.
Are we understanding
For
this?
C,
Yes.
for C,
Blink twice if you need help.
so for C is 256.
Hmm?
For C is 256.
Yes. Do you understand? Like, now, I'm telling you that IP.
What about for class D? That has
Class D, everything is taken to the network ID. It's the network. They just broadcast to people. It's radio stations. Nobody is joining them. They just broadcast to as many people, and this is reserved. Now that I'm showing you the, yeah, catch me, but I don't think so. So now, I'm showing you the IP, how IP is calculated. Now I'm telling you that when you say base 2, how many numbers are in base 2?
3.
Base 2.
4.
Hey!
0, 1, 2. 0, 1.
If I'm talking about binaries, what are you going to see in binaries? 0 and 1. That is base 2. Now, if you say base 3, you find 0, 1, 2.
Yes.
Base 3. Now, normal numbers in mathematics is base 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you dey do plus and minus in normal base 10, you carry 1. If you reach 10, you carry 1. Then I'm going to teach you that one. You don't know that go your house. That go your house. Do you understand what I mean? Now, let's say IPs are in base 2, 5, 6. Meaning it can contain 0 to 255. Do you understand? How did it come about? Make it not be like saying I dey give you now.
That does not change.
Because it doesn't change.
It doesn't change. It doesn't matter. You have 8, 9, 10, 255. It does not change. I don't think
I want you to understand. It's not a constant though.